I will be presenting the introduction to our report, which is on analysis of phosphorus concentration in river water samples using UV visible spectrophotometry. This technique plays a vital role in environmental monitoring, especially for tracking nutrient pollution in aquatic ecosystems. Phosphorus is an essential nutrient, but when present in excess due to agricultural runoff or sewage discharge, it can lead to eutrophication. This process stimulates the excessive algae growth, which depletes oxygen levels and harms aquatic life. Hence, monitoring phosphorus levels is critical for water quality management. In this experiment, we aim to determine the concentration of phosphorus through river water samples by measuring the absorbance of phosphomyelite complexes formed in the presence of phosphorus compounds. These complexes absorb light at a specific wavelength, allowing for a quantification through spectrometric analysis. Using standard solution of known phosphorus concentration, we constructed a calibration curve by plotting absorbance values against concentrations. Then we analyzed the absorbance of our river water samples and used the calibration equation to estimate their phosphorus content. With the context in mind, let's move on to the materials and methodology that we used to carry out our experiment.
Methodology: first, collecting sample, where we collect river water sample using clean acid wash polystyrene bottle and make sure to rinse the bottle 3 times with the sample water before final concentration. And after collecting the final collection, label the water with data, time and location of the water sample, and repeat it with sample 1, 2 and 3. Second, after collecting sample, we have to prepare sample. First, we have to use 0.45 membrane filter to remove suspended solid from the sample water, and acidify sample to pH below 2 with concentrated nitric acid to preserve the analyte. Second, make sure the sample are in room temperature, then add ascorbic acid for molybdenum blue method for phosphorus detection. Then repeat step 1 and step 2 for each sample. Then allow all the sample rest for 10 minutes before measurement. After that, we have to prepare 5 standard solution. First, from the standard solution, prepare working standard solution with concentration 2.5, 3.5, 5, 7.5 and 10 mg per liter by diluted it with distilled water in a 100 ml volumetric flask, and add the same color developing agent, which is ascorbic acid for molybdenum blue method, to each standard as done for the sample, and allow the color to develop for 10 minutes. Lastly, we have to measure absorbance using UV visible spectroscopy. The first thing we have to set up is wavelength. Use 880 nanometers since this experiment used molybdenum blue. And for blank calibration, we can use a region blank to zero the instrument. And for the standard solution and sample curve, first measure absorbance for each prepared water sample using the same setting. Before measure, we have to ensure cuvette are clean and match. Then we can run the measurement and repeat for other standard solution and for sample solution 3 times.
Hello, my name is Nur Maisara binti Edward, and today I will be presenting about the calculation part. As shown in the table below, the absorbance increases with concentration, indicating a direct relationship suitable for constructing a calibration curve. Figure 1 shows the calibration curve with a strong linear relationship, confirming the reliability of using absorbance to estimate unknown phosphorus concentration. On the x-axis is the phosphorus concentration, y-axis is the absorbance, and the trendline equation is y equal to 0.0255x minus 0.0067. The R-square value is close to 1, which is excellent linearity. This equation allows us to find unknown concentration from absorbent value. There were 3 replicates of the river water sample were analyzed to ensure accuracy and consistency. Then we used the average of the absorbance to calculate the concentration. The average phosphorus concentration in the river water is approximately 0.6039 mg per liter. This value lies within the stated concentration range within 0.1 to 0.5 mg per liter.
My name is Ashwarya Adawia with metric number BS23110365. For my part, I will focus on the importance of quality assurance and quality control in UV visible spectrophotometric analysis. I will explain the specific QA and QC measures applied during the phosphorus concentration determination in river water samples and why each of these practices is essential to ensure accurate and reliable analytical results. Both QAs and QCs are cornerstones of accuracy, reliability, and consistency, ensuring confidence in the results. They play a major role in producing a data that is both trustworthy and scientifically valid, especially in environmental monitoring, where even small errors can lead to serious misinterpretations, making thorough QA and QC protocols necessary throughout the entire analytical process. The first essential aspect is to replicate measurements. It is carried out to evaluate the precision of the method. By taking 3 separate readings for the same samples, it becomes possible to assess the consistency of the result. Small variation between these replicates indicate a high degrees of precision, confirming that the method is stable and reproducible. Next, blank measurements are performed by using distilled water to zero the spectrophotometer. This step is crucial because it removes any background absorbance from the measurement, ensuring that the recorded absorbance values are attributed only to the phosphorus content in the samples. Instrument calibration is also important as it helps to ensure that the spectrophotometer operates at the correct wavelength, which is particularly around 880 nanometers for phosphorus detection. Regular calibrations maintains the instrument sensitivities and prevents measurement from drifting over time. And lastly, calibration curve validation is performed to confirm the accuracy of the spectrophotometric measurements. A strong linear relationship indicated by R-square values that are close to 1.0 demonstrates that the instrument provides an accurate and predictable response across a range of phosphorus concentration. In summary, quality assurance and quality control measures are indispensable in analytical process. Implementing a strong QA and QC measures guarantees that the analytical data provided is precise, accurate, and dependable, forming a sound basis for scientific interpretations and environmental decision-making.
In conclusion, the researchers successfully determined the concentration of phosphorus in the river water samples using UV visible spectrophotometry. This method showed excellent linearity with a coefficient of determination R-square of 0.9992, indicating high reliability of both the instrument and the technique. The measured phosphorus concentration was 0.6039 mg per liter, which falls well within the expected range. This value also demonstrates the precision of our results, supported by consistent absorbance reading across all replicates. With proper quality control measure in place, the data proved to be precise and dependable, confirming that this technique is well suited for environmental water quality monitoring. Thank you.